Okay, here's the end, and then we'll try to put in some examples. That's the biggest pro tip for these problems is don't forget the last part. I have people, oh, I didn't see that last part. I didn't I didn't check that. Okay. That's why we'll train you with these tests to go fast through this for 15 minutes, and then that you're like saving yourself the last 2, 3, 4, 5 minutes to double check. Okay. On mine test it will be okay. And then on the real test, I used to have a semester final where I would race people through these, but oh well, we don't have that this time. Okay, the same block is projected up with the same speed and comes back down the ramp. On the axis, sketch the graph of velocity that is a function of time for a motion of the block while it goes up and back down the ramp at time tf. Explicitly label any intercepts, maximum, minima. The ramp now has friction. Okay, so they made up a new problem with the same block. It trails off from the end of the ramp after having no friction. Now the same thing does have friction. Okay. Um, let's see. What you need to know, so friction opposes motion. So acceleration on the way up, I made a mu for some reason. Acceleration on the way up the ramp is now going to be greater than g sine theta. Or actually less than negative, right? It's the enhanced acceleration. On the way up, it's going to be more negative than minus g sine theta because it's accelerating down. And then when you accelerate, when you're going down, it's going to be greater, more positive, less negative than minus g sine theta because it's trying to fall down. It's going that way. So I should be extra steep Oh my goodness, this is going to stump me. It arrives at the bottom at time tf. If the acceleration is changing because its friction is resisting it the whole time, but friction is helping gravity while the block slides up the ramp, and friction is opposing gravity while the block slides down, should I really hit the top at tf over 2? I think not. I think it should be before. It should take a longer time to come back down. Like it should get to a stop really fast and take a longer time. But I definitely should have v equals 0 at tf. So I want some here. So I want a steeper slope. And remember, down the ramp is positive. Oh! So these are backwards again. And then I should have one that's still like, and you're always accelerating down the ramp. Oh. Okay. So on the way up, it is greater than plus g sine theta. And on the way down, it's less. And this is the slope. Okay. Does that answer some curiosities that you had about how to answer that? Let's see if I really was stumped. Maybe not. I've done this enough times. Over years. Okay, the graph has two straight line portions for having a change in slope at v equals 0. Okay, so just having that kink in the graph right there, the change in slope or in angle, that was 1 point. So if you didn't have a bent graph like that, we're already down to 2 out of 3. For having having slope values, each segment must have the same sign, could be both plus or both minus, and the correct relative magnitudes. Okay, you have more because gravity is helping and then not helping. Sorry, friction is helping gravity and then not helping. So this one needs to be steeper than that one. But you could have, if you inverted the axis like I started to do, that would have been okay for the second point. Okay, and then for having a graph, the third point, for having a graph that crosses earlier than t over 2. Because you're going to quickly get to a stop with friction helping gravity slow the block down, and then it's going to take longer to reach the bottom at slower speeds with resistance. Any questions? Can can you estimate what you would have got? We talked about the points along the way. Mark your whatever your score is. That's not the points that you're getting. You'll get full credit for having corrected it. We'll turn that in at the end of the hour. Okay. Give yourself your grade you would have gotten on this homework. I need to start giving these. I need to give at least one with a block on an incline and maybe a pulley for real homework points that I will check. Or actually, it would be better practice if we tried that one for 15 minutes in class. You want to rehearse after some examples. Okay. So, let's go over my plan. Online classes will be a bit behind, just because of technology limits. But here's the plan for the end of the first unit. There it is. Okay. There are really only 4 topics, and we kind of breeze through them. There's one-dimensional kinematics with our equations of motion. Hopefully you know what the first 2 are, and that's the famous third one that they're always trying to get us to use. There's 2-dimensional motion with projectiles and vectors. I feel like we're good on those. What we could do, if you're not sure, we could try the honors chapter 3 test with the projectiles. Was it kicking a soccer ball or a baseball or whatever? And then it had like swimming across a river vector problems at the end. College Board loves to throw in one good airplane drops something, someone swims across a river, boat crossing a river or something that's just a straight vector problem. Probably 1 on the test out of 20-some questions, or 35 on the real test. But it helps if you can do those. They're not that hard. Do you feel solid doing my test? Give me thumbs up. Or you want to try the honors and like correct it or go for extra credit? We can do blue-green. Thumbs up for your board with vectors and projectiles. Just you can just sign to me. Or thumbs down, you need more practice. I want to do the honors quiz. I'm not seeing many thumbs down. Some people shrugging. I could give it as like a homework. You try it and correct it real fast. It won't take you 40 minutes this time. It'll take like 20. You'll be amazed how you've improved. Okay. We've got motion, projectiles. Okay. The problem is we've also got Newton's laws. Okay. So I thought actually for the rest of this week I should go over Newton's 3 laws and their examples. Okay, because that includes like inclined planes, inclines, Atwood's machine, and pulleys. And all variety of, okay, acceleration is the sum of the force over mass problems. And I actually found a whole bunch of example free response and multiple choice questions that we can try and do that. But I thought we should do a fast-paced lesson. It's already 9:30 today. 15 minutes to go. I'm sure you need a brain break. Okay, and I'm tired of talking into this thing. But those are the only topics on the first test. So, and you just breeze through those first 2. That was easy stuff. Seems like a little bit of confusion with Newton's laws and the angles and inclines. That's okay. So we'll spend a little more time reviewing that. Big news, especially since we're dealing with extenuating circumstances stuff this year. If we need to, like, if we end up only having 1 test this quarter, although the second test just adds momentum, which is really easy, we can do that. So you can have the option. We'll take 1 test, And if it feels like we need to like scramble so people can bring up their average or something, like if you have a bad first test and you want to have the other one, or you're just really ready, we can do that, or we can push that second test to the next 9 weeks. I don't care this year. We could, but that means that, and that actually, that's an advantage. If everyone does super well, the first one we could get in 3 tests really quick in the second quarter, and that averages them out. They're probably because the first one is earlier. We do have to do rotation and oscillations, and rotation just is hard. Oscillation shouldn't be hard, but it's usually right at the end, right? Like after Thanksgiving, the end of the semester, it's really hard to pay attention. So it's just the timing of it. Any questions? Okay. Let me stop recording. I can't leave you with nothing. I got to give you an idea of what we're going to do.